Members of the seminar, I would like to bring your attention to our final speaker, coming all the way down from Johor, Malaysia, introducing Professor Insinyur Dr. AMIR HASHIM Muhammad KASSIM from Universiti Tun Hussien, Malaysia. Professor Insinyur Dr. AMIR HASHIM worked as a professor at Universiti Tun Hussien, Malaysia, Department of Water and Environmental Engineering. He has earned his PhD on hydrology and water resources from University Birmingham, while earned his Masters of Science in Hydrology and Water Resources from Colorado State University. Professor Insinyur Dr. AMIR research interests are in flood control, rainfall runoff modeling, and also grey water quantifications. With that, I welcome
All right. Thank you very much. I would like to thank to this invitation given to me. I want to change my topic. Instead of the proposed, I would suggest this topic which I'm going to share with you is something which I have done some research on rainwater harvesting with my colleague, Dr. Hafizi Muhammad Lani from UTHM, and my name is AMIR HASHIM bin Muhammad KASSIM. So the topic of my discussion will be on combining cost benefit and reliability analysis of rainwater harvesting system for commercial building. Our research we have done at Iskandar, Malaysia, which is a new city down south in Johor. We believe that by the year 2025, we might face water crisis because the water demand is rapidly increased compared to water supply. At the present time, they are getting water from a river, which is 67%, and dam 33%. So we know that we are facing a lot of problems of water supply. Even currently, we having problem in Selangor because of river pollution. So if you cannot control this consistently, it may happen also in Johor. Why should we have alternative resources required? Because of the rapid increase in water demand due to growth population and industrialization. So in Johor, especially Iskandar, the population growth is quite rapid. And we have limited raw water. Some rivers are over-extracted, and also increasing costs to transport long-distance sources. River pollution, which is quite common here in Malaysia, and also we used to manage water crisis. So this study focused on exploration of rainwater. This is the alternative that we have. We are quite fortunate to have plentiful of rainfall compared to other water resources. Our high rainfall, which is average of 2,400 millimeter per year, and we have very short dry days, which is about 2.75 days. The present scheme in Malaysia, we know that we do have this rainwater harvesting, but it is not quite practiced all over in Malaysia, but it's not attractive because of we are competing for space. We are having a saving which is insignificant. Our water tariff is quite low water consumption, and the installation of rainwater harvesting is quite costly. But in other countries, it is quite attractive because they have high water tariff and high water consumption, high roof area, and possible to provide better economic return. So with all these problem statement that we have, so the main objective is to evaluate the performance of rainwater housing for small and large commercial buildings by assessing its supply reliability, economic benefits. So the specific objective of this study, actually basically before this we have 4 objectives which include development of software, but in our seminar today I will just mention 3 objectives. Namely, number 1 is to estimate water consumption for non-potable uses at commercial buildings. Number 2, to determine reliability of rainwater harvesting systems for different tank sizes based on long-term rainfall data and water consumption pattern, and to examine economic benefits of rainwater harvesting in commercial buildings for various water tariff scenarios. 2 buildings, which is in Johor Bahru, we use Taman Universiti Ion, and which we consider a small building, and Ion Bukit Indah, which we assume it as a big building, are selected as the commercial building models. Water consumption data were monitored daily and combined with the secondary data, and we obtained long-term rainfall data from the Senai International Airport Station. Reliability and economic analysis were investigated for different tank sizes and future water tariff scenario. So we know that through the literature review, the benefit of rainwater harvesting system in Australia in terms of economy, the annual domestic cost saving is up to AUD $240 per year per house. And the environment in South Korea, the rainwater harvesting is predicted to reduce flood by 10%. It is true that using rainwater harvesting, it can reduce especially flash flood in urban areas like Johor Bahru and in Uganda, improve household water management rural area and reduce water-related health risks. These are the tables of different findings from different countries. For example, in residential areas in Australia, the annual cost saving is up to 240 Australian dollars per year per house. In Greece, meeting full demand, 100% reliability. In China, it can capture 70% to 63% of stormwater, which obviously will reduce the event of floods. In Germany, potential water saving is up to 20%. In commercial building in Portugal, water saving is up to 60% with a payback of 19 years. After 19 years, what I mean is that they can get profit out of it. Water saving to 50% with PBP of 2 years. This is there are 2 locations, one in Taman Universiti, which we consider as a small building, and Bukit Indah, which is a large building in this case. And the area for the small building is 16,506 square meter, and for the larger building, which is Bukit Indah, which is 95,760 square meter. So for each building, we have identified the collecting tank, distribution tank, and the piping system. So what we look here is the top view of the down part. Down part is in this picture. The water from the roof goes down through this down part and finally to the drain. And This is the flow chart of what we have done from start. We used to find the water consumption pattern, daily water consumption, monthly water bill, and we calculate the reliability analysis using the mass mode balance model. From the Sungai International Airport, we obtain the daily rainfall data, which also include the roof area. The cost benefits evaluation includes the electricity tariff, interest rate, water tariff, replacement of tank, system lifespan, replacement of pump, retrofitting costs. And from there, we get the net present value, benefit cost, the return of investment, and the payback. So these are physically what we got from the reticulation system, the costing of tank, pipe, pump, and so forth. This is a simple calculation to get reliability analysis and also the economic analysis to calculate the net present value, benefit cost ratio, payback period, and return on investment. So the analysis will be based on these 4 parameters. So what we have obtained from the research, the large building, and mention about the rooftop area, that the length of proposed pipe system is about 890 meters, and it's shorter in a small building, which is 446 meters. And the average daily water consumption in the large building, since it's having a bigger population there, the consumption is 535.7 meter cube compared to the small building, which is 213.9 meter cube. These are the other details that we got from the buildings. So the commercial building, small and large, this is what we can average the parameter of tank size, which is 200 to 1,000 meter cube. The tank size for the large building is 500 to 6,000 meter cube. So at present, the water tariff is 3 ringgit per meter cube. So if we estimate that maybe in 10 years, the water tariff will be increased to 4 ringgit per meter cube, and in 20 years, the tariff will be increased further to 4.7 ringgit per meter cube. So we are quite fortunate that the government has already decided not to increase water tariff for this year. These are some other parameters that we use for runoff coefficient. The unit is 0.9. So we get a reference from Waterfall 2004. Cost of tank is 50 cents per liter. Cost of pipe, 24 ringgit 10 cents per meter. We obtain this reference from Ministry of Works 2015. The maintenance cost, we estimate 133 ringgit per month. Retrofitting, 4,000 ringgit per pipe. Electricity tariff from the TNB, which still we use on the year 2014. Maybe in the year onwards, the value will be increased. Water tariff right now under Suruhanjaya Treatment Ice Pan, which is $3.05 per meter cube. So we estimate that the tank will be replaced after 30 years, the pump 10 years, and the lifespan of the system hopefully can stand for 30 years. And this is some outlook of the rainfall data at Senai Station from 1975 to 2003. So there is a large fluctuation of rainfall, and we can summarize that maximum daily rainfall is 364.4 millimeter, and we have average daily rainfall of 11.87 millimeter. Average annual rainfall is 2,400 millimeter, which is quite high. We in Johor, we receive water quite abundant, and we are very blessed with the water that we obtain almost throughout the year. These are the graph for small building and large building. So monthly water consumption for toilet use is how the pattern looks like. Almost monotonous. Plant watering, landscaping, and chiller system, aircon, we can consider that it goes quite straight. Right? There is no large fluctuation. For large building, it's even more consistent, but with higher water consumption, yeah, about almost 8,000 compared to the small building, which is about 2,000 meter cube. And the condition for aircon for large building is obviously bigger compared to the small building. They use almost 10,000 meter cube compared to small building, which is 4,000. This is the percentage of reliability, which is up to 100% for the big building, and for the small building is just 93%. So comparison with the present the range, the tank size range, which is 10 to 220 water use for livestock, if you refer to Londra 2017, is 100% reliable. And for lawn irrigation and toilet flushing, 1 to 1,000 meter cube, the maximum reliability is 35%. But compared to our present study, which is higher in tank size for the bigger building, 500 to 6,000, which we use for non-potable, is 100% reliability. So this is the water tariff trend for Johor, Malaysia, from 1965 to 2015. We can assume that it's a straight line which has a coefficient of almost 0.9. So we estimate that the next 10 years, it might be 4.5. So by this time, by the year next 10 years, next 20 years, rainwater housing will be more attractive, will be more economical because of the pricing, which make the economic analysis which is more viable. This is another economic analysis for small building. We see that the large building is giving better net present value, return of investment, and also the benefit cost ratio, which is better. So a bigger building will give a better economical values. And this is the calculation we use that for small building, for this water tariff, the payback is about 10.5. If we have a bigger water tariff, it goes slightly lower, about 7.5, compared to the large building. You see that as the water tariff increases, and if you increase the tank size, the payback period will only goes to a smaller year, 3 years. Meaning to say, in 3 years' time, if you use this large building with the future water tariff, the cost will be less. We have a payback period of 3 years. So if we compare with the present study, in Malaysia, the payback is 3 to 10.5 years in Malaysia, compared to Portugal, 19 years. Australia, 30 to 46 years. You even cannot enjoy what's happening, what research you have done after 46 years. Actually, I'm old now, 46 years, I don't think I can survive. So, in conclusion, since we have 3 objectives, to estimate water consumption for non-potable house users at commercial building. So these are the values that we achieve for the small building, 1,587 to 1,012 meter cube, 793 1,006 meter cube, and 3,075 to 4,024 meter cube for toilet flushing, plant watering, general cleaning, and chiller system. And the corresponding large building, which has a bigger water consumption. So of the total water consumption, the non-potable users make up 68% for small building and 70% for large building. Objective 2, to estimate reliability of rainwater harvesting system for different tank sizes based on long-term rainfall data and water consumption pattern. So based on that, the maximum reliability is 100% for the large building. This is a good finding compared to the smaller one. And finally, the third conclusion would be when we examine the economic benefits of rainwater harvesting system in commercial building for various water tariff scenarios, we suggest that the optimum tank sizes for the small and large building are small building 600 meter cube, and for large building 1,600 meter cube. For 3 different tariff levels, 3, 4, and 4.7 ringgit, the payback for optimum tank sizes of 400 meter cube to 800 meter cube for small building ranges from 6.5 to 10 years. For large building, the payback from 1,400 to 1,800 meter cube range from 3 to 4.5 years. So in this study, we suggested that large commercial rainwater harvesting system resulted in better NPV, ROI, BCR, and payback compared to the small system. This is because the large building provide 5.8 times bigger roof area and 2.5 times in terms of water consumption compared to the small building. So, contribution of knowledge, we see that this study provides comprehensive reliability and economic studies. Technology, I haven't mentioned in this study that we have developed a software, and for nation society, large-scale rainwater harvesting could provide alternative options for government building owner to complement current water supply resources. Thank you for your attention. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Thank you, Professor and Senior Dr. AMIR HASHIM, for the discernment of the issue from the costing point of view in rainwater harvesting in Malaysia. May we be able to apply this in the future for larger building and try to cut the cost then, inshallah, then, and earn more then, inshallah. Right? Ladies and gentlemen, members of the seminars,
can I have a question
is there any questions for Prof. AMIR?
Yes, I have one. Can I have a question?
Before I run out the
Dr.
sessions,
Okay.
Mr. Gary Lim.
Yes, okay. My name is Gary Lim. I'm an engineer by profession. I have great passion on rainwater harvest system. I always disagree.
Is there any question for Prof. Amir?
I always disagree with the tank sizing method. Reason because the tank size is based on very big figure. I always say, it should be based on toilet flushing, where you already mentioned. We should size the tank for toilet flushing because that is the one that uses the most water. You treat the water all the way and then you flush in the toilet. While we drink treated water. In this sense, the methodology in sizing tank size end up the project cost is very, very, very expensive. So just please ponder over. Landscape water is dispensable. Toilet flushing is not dispensable. Drinking water is not dispensable. Why treat so much water to drinking quality and flush door in the toilet? You look at all the places in all the university, everywhere you go, how much of your toilet is being flushed by rainwater? Narim, I've been there. They flush it to toilet water because it is part of the objective. Look at all your universities, all are flushed with treated water, very expensive. Please ponder over and never size the tank to so huge. It's ridiculous, 50 meter cube, 20,000 meter cube for a small building is terrible. Ponder over. We always have treated water available at all times. You must have a good system, a simple system just to ensure treated water replaces. That is my comment. Ponder over it.
Okay, thank you very much for the suggestion.
Assalamualaikum.
Into that.
Tuan Speaker. Halo. Assalamualaikum, Speaker.
Waalaikumsalam.
Yes. Would you like to introduce yourself, sir?
Hello. We have a problem here.
I am Speaker.
Yeah.
Indeed, very interesting of your presentation. I would like to ask, is there any alternative of cheaper installation cost? I saw in your presentation, the cheapest pump alone is about 38,000 for a small dwelling. Our objective is to make sure or to campaign for dwelling, especially in urban areas, to embark on this project. Any options in terms of costing?
Well, I did mention in my presentation that the cost is based on reference from Ministry of Work, JKR. So any option would be, we'll look into a cheaper pump then. But the one that we do was on commercial buildings. Commercial building, which is quite big in space, and obviously the owner of this building, they are quite they can afford to have such thing. I think we can find a better pumps because there are many in the market.
May I just add to this? I would like to propose gravity feed. Recently, I presented a technical paper to the ASEAN engineers, AFIO. No pump required. Gravity feed is workable, and the tank size don't have to be so big. I said again, only for toilet flushing. You don't want to do anything else. Gardening, they are dispensable. You don't water the garden. We talk about necessary water. Gravity feed. This is something which is never promoted heavily. Pump needs maintenance. I tell you, there's 101 problem. Your underground tank is all filled with sludge. Check all the tanks you have. All filled with sludge. The pump doesn't work. You cannot go inside an underground tank. It's called confined space. To clean the tank is a nightmare. So all the system, I believe, currently installed 5 years ago, all are not working. Trust me,
Okay.
I done my research. Right? Nobody follow gravity feed. That's the simplest idea. Okay, you want the technical paper, email to me, I'll send you. A technical paper giving all the concept, gravity feed.
Good, Jason. Thank you.
Any comment, Prof. Amir?
Okay, Professor Amir.
Yeah.
I'm from UTHM.
Dr. Shukriya.
Firstly, thank you very much for this, Dr. Amir, as a keynote speaker today. Straightforward, my question is, based on your research and experience in this field, what do you think now the minister should do? That's all.
The minister should do for what? Is it for rural areas?
The application for this rainwater harvesting.
Yeah, I think it is quite, important that, especially the event which occur nowadays in the big cities, urban areas, we have flash flood. In Kuala Lumpur, there is no means of how to really control this. I believe that having rainwater harvesting or tank on top of tall buildings, it will reduce this event remarkably obvious. And then for rural areas in Kelantan, we have problem of water quality when you extract water from groundwater. So again, the only possible alternative will be rainwater harvesting, and with good treatment, it will better off the treatment plant that we propose. In Israel, it's quite, I think we know that they have invented a machine getting water vapor, I mean from the humidity, relative humidity, which they can then produce water. You know, this technology is really fantastic, because you can put anywhere on earth that you can produce water without any disturbance, any pollution which affect like our river water, because there are many factors for us to control water pollution. But relative humidity is something atmospheric, it's open. So this is one big technology which I saw that the Israel they have invented that technology, and we in Malaysia we have abundance of what we call relative humidity. It's about 80%, which is barely, we don't use anything from it. Obviously the minister, they will have to envisage on the research of rainwater harvesting further.
Thank you very much.
Welcome, doctor.
Thank you so much, everyone, for the what we call it comments, and I can sense intense in the air, but it's a very good discussion. Then it shows that everyone is putting in their all attention to these issues, which what we call it hopefully will benefit us Malaysians and the rest of the world who are listening, inshallah, then in the future. So, ladies and gentlemen,
Assalamualaikum.
On behalf of the committee, I would like to express my utmost gratitude to all the distinguished keynote speakers and the members of the Zoom for making the opening ceremonies a success. Alhamdulillah.